episode 5 of Battleships. In the previous episode, we wrote this game board class that represents the entire state of the game, so both the battleships and the shots that have been taken, and we added logic to it for how to update the game board when an extra shot is taken by our player. In this episode, we're going to get very close to finishing our one-player version of Battleships. We will hook up our game to the input that our player gives us. We will end the game when all of the battleships have been destroyed, and we'll also render an admin board, or just a more in-depth board that includes both the shots and the battleships that are in the game. We've got these points down here. Render this admin board, hook up our player input into our game engine, and then figure out how to end the game when all the battleships have been destroyed. Before that, again, I forgot to commit our work from last time. So we go git add dot to stage it, git status to check it out, and then git commit to add it, commit it into git. And so last time we added the game board class. Let's start with this render function. So we have a couple of different render functions. We have one that prints all of the shots and one that prints all of the battleships. And they're both very good and useful, but it would be nice to combine them into a single render function that prints both shots and battleships, just to help with debugging. And what we might also do, we'll see about this, but we may want to add in a flag that we can pass into our function that allows us to toggle whether or not we want to display the battleships. Because if you think about it, when we're showing the board to our player, we don't want to show them the battleships. That would take away all the fun of the game. But when we're debugging, we do want to see the battleships so that we can see how the whole game is working. Let's start our function. Let's do it up here because it's going to take place of this other function. We'll call it render2 for now. It's not a good name, but we'll change it once we've deleted our previous render function. And you'll see here immediately something new, that we can pass in. We don't have to pass in board width, board height, shots, battleships separately, because these are now all wrapped up in a single game board class. So we can just pass that game board object into our render function and then pull off all of the bits that we need. Because remember, the game board knows about the battleships, it knows about the shots, and it also knows the dimensions of the board as well. A lot of the logic will be the same. We can borrow it. So we're going to want to print the same header. And now we have to think about how to combine the two approaches that we took for both shots and battleships. Let's take this approach from our battleships. So we'll copy it over and then talk about it. If you remember, we rendered our battleships by first constructing this 2D list, this 2D board here. So that looked something like, it was a list where each element in it was itself a list. Then we added into the appropriate coordinates of this 2D list, we added characters to represent our battleships. And then once we had this data structure, we all we needed to do was to print it out. And we're going to do something very similar here. We're going to keep this bit exactly the same, actually, because once we've got all the characters in our board in the right place, so we've got the characters that we want to represent the battleships in the right place, the ones we want to represent the shots, the process of printing them out is just exactly the same. You just go through each row in the board and print it out and join it up. What we're going to need to change, well, for starters, we're going to need to change this, battleships, because it's no longer just battleships because we're not passing that in as an argument. Instead, it's gameboard.battleships. In fact, that is it in order to make this bit work again. And before we work out how to add in the shots, let's just print our header down the bottom and see if this whole thing works. Since we're not going to need them, I'm going to optimistically delete our old render functions as well. They're old news. And that means we can get rid of the 2. Oh no, that's absolutely not what we're going to do. That is, however, we can call it render now instead of render 2. Let's find a game board. We've got one here, don't we? Let's get rid of these. And here we've got our game board. We've taken a few shots on it. So let's render the game board. Didn't work. Ah, of course. So line 63, it's no longer board width. Instead, it's game board dot board width. You could argue that we don't need to call this board width anymore. It's obviously the width of the board since it's a property of the game board object. And in fact, I think that's correct. So we should just call it width and height rather than board width and board height, just to save a few characters and make everything a bit easier to read. First, let's go through the rest of our code, make sure we haven't made the same mistake anywhere else. Well, we have made the same mistake in many other places, so let's fix it. Done it on line 76 and 78, and I think that's it. Great. So this works. It prints out the battleships again, just like it was doing before. Before I forget, let's use this fancy editor command to change all board widths to widths and all board heights to just say height. Let's make sure that didn't break anything. It did not. Now we need to add the shots to the board. Our work is made slightly easier here because say we have a location in our board. Let's make a little scratch file. Say we have a location in our board that has both a battleship, so here's our battleship, well, we've been representing them with O's, and a shot taken in part of it. We know we always want that shot to be rendered on top of the battleship. We know that the shot always takes precedence over the battleship. And so we can actually, rather than having to do any fancy logic to figure out what to do when a battleship and a shot collide, we can just print all of the battleship coordinates and add them to our board here, and then add the shots on afterwards. And if there is a situation like this where there's a shot on top of a battleship, it's not a problem. We just overwrite it with the character that we want to use for a shot, because the shot always goes on top. You could imagine more difficult, complicated rules that we might have to deal with for rendering our board. For now, we don't have to worry about them. We can always update and expand our process if we ever need to. So we can just iterate through our shots. And now we have our XY is shot.location. Is it called location or shot location? Yeah, we just called it location. That's good. And we're doing, once again, the same like deconstruction syntax, so that X is assigned to the X coordinate and Y is assigned to the Y coordinate. And now let's use a different character for if the shot was a hit or if it was a miss. So if it was a hit, let's use an X to signify a glorious hit. If it was a miss, it would be nice if there was a little dot you could put in the center of the board. Sorry, in the center of the square, but I don't think there is. No. A little X. We'll just use a dot for now. We'll try and figure out something better. And then we just go board X, Y equals character. That might be it. That looks pretty good to me. Again, maybe we can use better characters to make it look right, but I believe this logic is correct. Where have our shots been taken? Where did we take them? They were here. 1, 1, 0, 0, and 5, 7. So 1, 1, that was a miss. Yep. Sorry, 1, 1 was a hit. 0, 0 was a miss. And that is 0, 1, 2, 5, 7. That was a hit as well. Lovely. So that works. We've combined our two different renders into one. We can now, I mentioned that we might not always want to show battleships. So we can add a little flag, which is just an argument that is either true or false, deciding whether we want to show the battleships or not. And let's make it default to false so that you don't have to pass in that argument. And if you don't pass in a show battleships argument, then it will default to false and by default not show the battleships. And then we just change that to that. And now if we run it, this is what the player will see. And that makes sense, that this is a miss, this was a hit, this was a hit, and then they can keep going and adding shots. That means we have completed this first thing. Now we want to hook our player input up to our game engine. Let's actually do that last, because that makes, when we have to get moves from our player, it slows down testing a little bit. So let's instead first look at how to end the game when a battleship has been destroyed. There are two things we have to think about here. Actually, where in our game loop we want to check for whether the game should be over, and also where we want to store the logic for calculating it. And that makes me think, I know I said that we wouldn't connect up our player into our game, that we would do that after figuring out who has won or whether the game is over. But let's actually hook up our game into this player loop first, so that we can then look at where we want to put the check for whether the game is over or not. Let's see, what do we need to get rid of? So this we don't want to do anymore. We don't want to hard-coded in those shots. Don't want to do that. And we don't need this shots. You see we had this shots array, the shots list here. We don't need that because game board is taking care of that. And now we can update this logic here to use our new structures. And as you may have seen as our program has gone on, we've often deleted code that we've previously written and just replaced it completely wholesale. But that doesn't mean it was useless, because here we're going to replace shots.append with gameboard.takeshot. And we're also going to replace render with just render gameboard. And even though we've deleted code there, the structure of the code is still similar. We've still gained a lot and understood a lot about our program by writing this first iteration. So just because we've deleted some code there, that doesn't mean that it was a waste of time or that it was unnecessary. It was a vital part of figuring out how we want to do things. Let's see if this works. It might just work for now. Where do I want to shoot? 0, 0, 1, 1. And then I happen to know, I think we've got a shot here. Oh, that was a miss. Bummer. Anyway, you can see that it's working. We've hooked up our player into our game engine. However, if I had the patience to fill through every square, the game wouldn't end. It would keep asking me, where do I want to shoot? So we need to figure out where the game should end. For now, we probably want to do the check here. So we'll want to do something like if game has ended, and we need to again figure out where to get that logic and where to put it. We'll want to print you win, and then we'll want to break out of this infinite while loop so that the game finishes and our program exits. And we could put this logic here. We could do something like go through each battleship in the game board, see whether it's been destroyed by looking at all of its segments, looking at that hits array that it's got, if you remember. This list here. And then if all squares in all battleships have been hit, the game is over. And we could do all of that here, and it'd be fine, it would work, no problem. But I don't think that's the right place to do it, because this little bit of code here, this is just gluing together all of the rest of the logic in the rest of our program. It's not doing anything clever. This piece of code here shouldn't really have to know much about the rules of battleships. I think it would be much better if we encoded that logic in our game board. So we make a method, something like is game over, and if it is, print you win. We can figure out better ways to communicate with our user, and then break. I think this is what our code should look like. And then this logic of figuring out whether the game is over or not lives up in our game board class. And this is often a pattern that I like to use when I'm writing code, is write the code as I would like it to look. So this is how I would like to write this code here. And now all I need to do is figure out how to implement this little piece. This is not too difficult now because we've broken it down. I've said I'd like an isGameOver function, and that doesn't need to take in any arguments because GameBoard already has all of the data it needs to know whether the game is over. You could argue, and I would have lots of sympathy with this idea, that these methods should not be on the GameBoard class. You could argue that GameBoard's only job should be to keep track of this information. It shouldn't know anything about what happens when a shot gets taken. It shouldn't know anything about what happens when, or how to know whether the game is over. And you might have another class called like Game Engine or Game Manager or something like that, and its job is to manipulate the game board. However, I think that the rules are still, for our game, sufficiently simple that would be just extra complexity for no gain. That no one's being hurt by the fact that we've added these two extra methods, the take shot and isGameOver methods, onto our game board. And adding in a second class would just make our program more difficult to understand, I think. As the game gets more complicated, maybe we have things like take shot, isGameOver. If you had new abilities like place new battleship or move battleship or something like that, maybe then we'd want to split out some logic. But for now, we don't have to do that, I don't think. We can leave ourselves the option of doing that. We could just pick up these methods and move them into a different class. But for now, I think we should leave things as they are. So as we've said, we now want to go in words. What we want to do is for each battleship, is it destroyed? And that's if yes for all, return true, else return false. And I think here we actually want to delegate some logic even further. So we could, in this method, look at each element in this this hits list, see if they're all true, and if they are, say, okay, that battleship's destroyed. But I think it's actually pretty reasonable for a battleship to be able to tell us whether it's destroyed or not. So I think we should write an isDestroyed method for our battleship, and that will return true if it's been destroyed and false if it's not yet destroyed. And we can do a similar approach to what we did before. What do we want this code to look like? I believe, well, let's write this out in both long form and then see how we can make it shorter using some of Python's built-in methods. We can say game over. We actually don't even need to keep track of whether the game is over. We could go for b in self.battleships if b dot is destroyed. Well, it's in fact if it's not destroyed, we immediately know that the game is not over because there's at least one undestroyed battleship. So we can immediately just return false. And if we get through every battleship without any of them triggering this condition, that means the game is in fact over because they've all been destroyed. And so we can just, if we get to this point, we know that we can return true. Another way of writing this, I believe, I'll have to go into the Python console to check this out, is I think we can just do it in one line with return all, then I think this will do it. Self. This is this list comprehension syntax that I think we talked about a little bit before. And you can kind of see what it's doing. It's saying well, let's see what it's doing in. Let's go 2, 4, 6, 9. Well, x equals 2, 4, 6, 9. If we go x is greater than 8, let's say y is greater than 8 for y in x, you see that returns it evaluates this condition for each y in this input array, input list, and then stores it in another list that it returns. So for the first 3 elements, y is not bigger than 8, so it goes false, false, false. For the final one, 9 is bigger than 8, so that returns true. And that's what we're doing here. B.is_destroyed for B in self.battleships will return a list for each battleship with true, true, false, false, true, depending on whether it's been destroyed or not. And what this all thing does is it, as the name might suggest, it returns true if all elements of the list here are true, and false if one or more of them are false. So in this case, as expected, it returns false. But if we said this, it's going to return true instead. And that's what we do here, and that gives us a nice little one-liner. We still have to implement this method. No problem though. We can actually use the same approach we used up there. If all elements in the hits list are true, so all elements of the body have been hit, we should return true, because that means it's been destroyed. If any of them are false, we should return false, because that means the ship is at least still slightly alive. And we can do that just like that. And now, I think that's all we've needed in order to implement our is game over. We can delete, let's test it out. So we can delete these two, or comment out these 2 battleships. So we only have this single battleship, which is at 1, 1, and 1, 0. So now if we play, I'm going to shoot at 1, 1, and 1, 0. And I win. And the program exits, and I can play again if I want. Maybe 2, 2. I remember now. I win again. Good job, me. We can get another tick for that. Maybe even 2. Is that it? Yeah, that was all we wanted to achieve this episode. Our one-player game is basically done. We could make it a little bit nicer, so tell a player when they have when they've hit something or when they've missed, maybe tell them when they've destroyed a battleship, things like that. But those are mostly, for the most part, just little bells and whistles. Let's go on to making our 2-player version next time. Yeah, we'll do that. So we have 2 players, each with different boards, each shooting at each other. This episode, just to recap, we made this render method using our new game board construct, and we made it so that you had the option to either show the battleships or not. We also plugged in our user input to the game board setup, and we figured out how to work out when a player had won or not. This time I'm going to remember to commit our work. We don't need this scratch file anymore, so we can delete that. Git status again, git add dot to add everything, git commit to commit it. And this was episode, I've forgotten, episode 5. Admin board, and we also work out when game is over. Brilliant. So I'll see you next time for when we start to make our game 2-player.